This is MAC 1105, Section 1.3, Part 2. This covers something that you should have seen in Algebra 1, Algebra 2, Prep Math if you took it, 1033, and it's just a matter of taking a formula that's written in one way and asking you to rewrite it so that you have solved for what's called the specified variable. We're looking at A equals L times W. That is your formula for the area of a rectangle. And it is solved for A because the A stands alone. Sometimes you have a formula in math or science that you want to rewrite so that a different variable stands alone. So this says we want to take the formula A equals L times W and solve it for W, meaning we want to take A equals L times W and rewrite it so that the W stands alone. So one thing you want to do is circle the letter you want to solve for, because sometimes you get into these that are a little more complicated. There's more letters and you forget what letter you're solving for. So we want to get that W to stand alone. And we have to do legal maneuvers to make that happen. Well, this is L times W. To undo multiplying, we divide. And we will divide both sides by L, which makes the L's cancel out over here. And we just have W equals A over L. And we have now taken that original formula and rewritten it for what's called the specified variable. In this case, it was W. It's just a matter of doing legal solving to get the prescribed letter alone. So we look over here, V equals 1/3 times BH. We want to solve this thing for H. Notice there is a fraction, which we didn't have to worry about over here. The first thing you want to do is multiply by the common denominator, which will make that fraction disappear. So I want to multiply both sides by 3. Over here on the left side, 3 times V is 3V. Over here, the 3 cancels with the 3, leaving just capital B times H. And incidentally, be sure you are using a capital if that's what they start with. Don't do all caps or all little. You have to have the same exact letters as what they have. So now I want to still solve for H. This is B times H. Just divide both sides by capital B. And my formula now is H is 3 times capital V over capital B. At this one, you might think, oh, I want to start by dividing by P, or you might think I need to start by subtracting D from both sides. You need to think about this maybe in terms of numbers. Pretend this was something like 10 equals 8 plus 2x. In that case, you would have subtracted 8 from both sides, which means I need to subtract D from both sides. Cancels that out, and this is T minus D equals PM. I want to get that P alone, so now I will divide both sides by M. Now there's 2 ways to write your answer here. You can leave it as one big fraction, capital T minus capital D over M equals little p. You can also think about dividing each of these individually by M. So I could have T over M minus D over M equals P. Both of those are acceptable. Do what you want. Let me say one more thing for why we undid this equation in the order we did. You have to think about order of operations, and really what you have to think about is reverse order of operations. If you were to do this arithmetic-wise, order of operations would have said we needed to multiply P times M, provided we knew what the P and M stood for. Multiply P times N, and then we would add the D. That would be the appropriate order of operations. When you are solving an equation, you must go in the exact opposite order. So the last thing I would have done in this evaluating order of operations means the first thing I do is to subtract the D. That's the main mathematical reason then I need to subtract the D. This was just an example with numbers that might help you get it straight. All right, a similar kind of problem here. We want to solve this for R. And if we think about this being order of operations, PRT means I would have had to multiply P times R times T and then add P to that, which means in reverse order, I need to subtract P from both sides. So this is capital S minus P equals capital P times R times T. I'm solving for R. Now PRT means P times R times T. I can get rid of the P and the T all at once by dividing both sides by PT. which gives me R equals capital S minus capital P over capital PT. And that is an acceptable answer. You are not allowed to look at that P and cancel those out. You are not allowed to cancel part of a binomial with a monomial. You cannot do that. Now what you could do is if you wrote this separately, S over PT minus capital P over capital PT, like we did over here. Now you could look at this fraction, not this one. There's nothing you can cancel with this fraction, but with this fraction, I could cancel the P's. P goes into P once, P goes into that P once. So this would be S over PT minus 1 over T equals R. So this simplified version or this version with the one big fraction are both acceptable. This one and this one both have fractions, so we need to get rid of the fractions before we do anything else. So I could think about this as n over 1. Now what I think about when I have a fraction equal to a fraction, I just cross multiply. So this would be n times, I'm going to go ahead and still write it as n times b minus c, and then a times 1 is a. Now I could have distributed on that step. I just wanted to keep it simple. So on the cross multiplying, I just put the n in front of the parentheses. Now I want to distribute. And what I want to solve for is b. To get the b alone, I'm going to have to add nc to both sides, which gives me nb equals a plus nc. And of course with addition, instead of a plus nc, that could be nc plus a. Doesn't matter a bit. The last thing is I want the b alone. So divide both sides by n, which gives me b equals a plus nc over n, which is perfectly acceptable. Again, you are not allowed to cancel that n with that n because you are not allowed to cancel part of a binomial with a monomial. However, like the last one, we could write this as a over n plus nc over n and cancel those n's. So I would have a over n plus c over 1, but plus c is just fine. So this answer right here is acceptable, or this answer right here is acceptable. One other comment on MATLAB when you are solving these, you got to pay attention to how they write the answer. If they write b equals, and then they have a box, if they have already put the b there, don't put in the box b equals whatever. Don't do a duplicate. So if they've already got the b there, don't put the b in the box. If all they have is a box, then they are expecting you to type in b equals, I'll just type that one because it's closer, a over n plus c. So just pay attention to the fine print on your MATLAB so that you don't make that kind of mistake. All right, last one, let's see if we can squeeze this in. This one over here, because I had fractions, I cross multiplied. Over here I have fractions, but I cannot cross multiply. Before I start multiplying, I'm going to spread this out a little bit so I can show the common denominator and the canceling. So the common denominator is ABC, so multiply by ABC times ABC times ABC, and then cancel. The A cancels, BC times 1 is BC. Here the B cancels, AC times 1 is AC, and over here the C cancels, and AB times 1 is AB. Now this one is a little different. We are asked to solve for C, but notice you've got C written twice on the same side. If this were 2C plus 5C, let's say, yes, I could put that together and call it 7C, but these are variables. I don't know what they represent. So the only way I can go from here is to get the C written one time on that left side. And the way I make that happen is to factor a C out of this term and this term. So factor C out of this leaves me with a B. Factor C out of this term leaves me with an A. And now if I can squeeze this in, to get the C alone, I will divide by B plus A, which cancels that out. I have C equals AB over B plus A. And again, I cannot cancel that A with that A. or that b with that b, because the b plus a is a binomial, you are not allowed to cancel part of a binomial with part of a monomial.